Good evening, everyone. Okay, I have a presentation here, so I'll just go over the presentation. Then, if you have questions, then I'll be happy to discuss the subjects that we touched on in this presentation. The title of this presentation is Opportunities for Smart Living in Dust, Heat, and Humidity. This is based on the research I have done in the past few years, in fact, maybe 7 or 8 years. And I'm going to focus on two things when it comes to so-called smart living. You know, renewable energy, reduction of carbon footprint. That's one thing that you can count as smart nowadays. And also, a lot of things are becoming autonomous, and you use robots to carry out various functions that do not require human intervention, at least real-time intervention. So I'm going to focus on these two things. First of all, you may have heard that Qatar has begun construction. Actually, I think it's about to complete or has already completed construction of its first major utility scale solar PV power generation plant. And the capacity of this power plant is 800 megawatts. That's a lot of power. This is about, let's see, about 6% of the national electricity production power capacity. Now, depending on which year you're counting. And last time I read the number, the national power generation capacity was probably 13 gigawatt, and that may have increased over the past year or two. But this is a substantial amount of electricity that's to be produced from solar energy. And you can see this Google maps, and then this is in a area that's to the west of Doha, and the place is called Al Karsa. Um, I'm sure that I'm not pronouncing the Arabic name properly, but you can look it up, and it covers an area about 10 square kilometers. It uses a tracking, one-axis tracking mechanism, meaning that all these black solar panels that you see in a photo, these are able to rotate about the axis as placed from east to west, so it can change its tilt. Okay, I'm not quite sure about that direction, but it can either tilt about a axis north, south, or east, west. I have not visited this site, so I will have to wait until I visit the site to be sure in which direction it's tilting. But the tilting allows it to be able to follow the sun more um, in a more rigorous way or more aggressive way so that you can get most of the solar energy from the sun. So over the past few years, my research has been focused on something called the soiling laws. And you can see from these three photos, looking at the same array, and this is a array of roughly 8 solar panels. And from top to bottom, you can see the top picture, these modules look very dark. That's because they're clean. The silicon elements, the PV cells inside the solar panel, it's a very dark material. So when it's clean, you can see the darkness of that material. But when the surface is covered in dust, you see the color of the dust. And so it's not so dark anymore. And when it gets very dirty, you can see it's all covered in dust, very dusty. Meanwhile, we can measure the electrical power output from these solar modules, and we can compare that output with the output that you would get if these modules are all clean, free of dust on the surface. So based on this, we can calculate something called the soiling loss. And basically, if you look at this photo, I'm sorry, this the chart on the right for the screen, and the vertical axis shows you basically how clean the module is, and in a quantitative manner. The horizontal axis is time. So you see the data points come down over time and then restore to a higher level. That's when you see the data points restored to a higher level, that's because cleaning. When you clean everything, then the cleanliness of the solar module gets higher, and then you can restore it to a theoretical value of 1, which means it's clean. But over a period of perhaps 2 months, you can lose the power production from a solar panel by 30 or more percent in a matter of 2 months. So that's a lot of loss. For that reason, people have to clean their PV modules if they operate solar power plant, solar PV power plant in such an environment. Here I show a compilation of photos of various cleaning solutions, mechanical cleaning solutions, and you see them in conjunction with the solar panels that they're about to clean. So largely, you can divide these cleaning methods into 2 categories. One is what I call frequent cleaning or daily cleaning. So they run these machines because these machines are installed on an array. For each array, there's one cleaning machine that's installed, and you run them daily. You want to run them as frequent as possible because otherwise, you've spent the money installing them, and then you want to get the most benefit from these machines, so you run them daily. If more frequent, then I imagine you could run it more frequently, maybe twice a day. However, in most cases, you probably run it daily. That's what I heard from people who sell these machines. Then there are multiple manufacturers that are making these machines, and then they have different designs, and some of them are relying on fixed rails, and then you need to install the appropriate structure along the solar array, and some of them can roam in a more autonomous manner without falling off the array, and then they have their own wheels, and they can basically run over the surface. And on the right-hand side, this is a different approach, and some of them have multiple applications, and some of the machines you can use them to clean solar modules, or you can use them to clean the high-rise buildings. Here you see in Doha or cities in adjacent regions, either in the UAE or Saudi, you have these glass facades that need to be cleaned periodically. And you could do it manually by hanging workers from the top of the building, or you can use a machine like this. So these are different cleaning solutions. So that's the technical background for this. And I want to, since this is a business-oriented conference, workshop, I want to, I know nothing about business, but I can see if you want to offer a cleaning solution to this need, which there is a need. Actually, I'm working with one of the co-owners of the 800 megawatt solar PV power plant, and they have another interest, which I'll mention in just a moment. That's related to soiling and cleaning. But if you want to offer a competitive solution to clean these solar modules, it needs to be economic. And then when I say that, you need to help the owner of the plant make money. So your capital investment, your operating cost should be justified compared to the benefits that it'll give the owner of the plant, the power plant. So the benefit of using your cleaning solution is that you will reduce the soiling loss so that you increase the electricity production. And how much the benefit is in monetary terms, it certainly has to do with the price of the electricity that you can sell to the grid. So there are quite a few parameters that you need to include in this calculation. What is also important is a long-term consideration. Most of the solar PV power plant generation projects have a design life of perhaps 25 years. Most of these cleaning solutions have not been tested for more than maybe 5, 8 years. So what they will do to the solar module over a 10-year period, 20-year period, the entire life of the solar power plant is yet unknown. So that will require some research, and also you can collect data from the field um, where there are power plants that have installed one of these solutions. So those two things you need to consider if you're one of those people who offer such a solution to for example, the 800 megawatt power plant in Qatar. Of course, there's some more fancy technologies, one of which is something that I have worked on, which is called the Electrodynamic Dust Shield, or EDS. I'll just briefly show this slide. This is I can tell you that we are honored to have earned a United States patent for this technology that we have developed. And we have tested the technology in the field. It does offer significant reduction in soiling loss, but it comes at a cost. And especially it comes at a cost to the manufacturing of the solar module itself. And you probably know the solar module manufacturing business is a very competitive business. There are only 1 or 2 countries in the world that are producing profit-making solar modules, and other entities have been pushed out of the market. So anything you do, if it increases the cost of your solar module, you do that at your own peril, and you may lose your market share um, in a very unpredictable way. So if you want to make a solar module that can repel dust from the surface, and you have to make it very, very cheaply. So we're not able to do that yet, and I'm not in a business of estimating the cost. I was able to organize an international supply chain to make these things for my research, but to do this on a business scale and have a realistic cost estimate is beyond my expertise. So another thing that is worth mentioning is the soiling sensors, or the purpose of these soiling sensors is to quantify soiling so that you know when you're operating your machine, your solar modules, you know how much soiling you are suffering. And by knowing that, especially for these cleaning solutions, which you do not have a dedicated cleaning machine for each array, and then you strategically time your cleaning events so that you reduce the amount of money you invest in the cleaning machines themselves, but you do it in a less frequent way, and then you hope that there's a trade-off between the capital investment of the cleaning machines and also the operating cost for them, and the cleaning benefits. So intuitively there should be a sweet spot that you have the optimized amount of cleaning machines, and then you will reap the maximum benefit. So to do that, you really need to know how much soiling you're suffering so that you can you can schedule your cleaning events correctly to maximize your return. So being able to measure soiling itself is not a simple thing. Technically, it requires a standard, an international mechanical commission standard, it's IEC standard 61724, that provides a standard method for measuring the soiling loss. But over time, people have developed many other ways to measure the soiling loss, because the standard method is a so-called gold standard method. As you can imagine, gold standard comes at a price tag, and you want to be able to measure it as accurately, but at a much lower cost. Over the years, there have been devices developed by, to my knowledge, two most well-known manufacturers of these soiling sensors. One is based in Austin, Texas. The company's name is Autonometrics, and they make soiling sensors. Another company is also well known. It's a bigger company, Kip and Zonen. They're based in the Netherlands, and they also make soiling sensors. Actually, myself has been working on a soiling sensor idea over the past year or two, about 2 years. So the method that I'm developing requires no electrical signal collection from the solar modules themselves. Instead, we place something that has a black and white contrast next to the solar module that you want to measure the soiling loss of. So you let for example, this checkerboard module, which has the black and white contrast, to experience the same level of soiling as your solar module. And as you can imagine, when the the checkerboard module gets dirtier and dirtier, this contrast gets lower and lower. And if you know how to do it by quantifying the characteristics of this image, you can actually connect that quantification with the soiling loss of the solar module. And so there are a lot of things we need to figure out. So we are still in that process, but I see some promise that this will become a way to actually useful in a commercial sense at a large scale. So when that happens, and then you can simply take a photo of this special module, and then you run a little program, and then within a fraction of a second, you know how much soiling loss your PV modules are suffering. So let me switch gears. So from the solar energy to smart living ideas that have to do with autonomous vehicles or autonomous mobile robots. And you have probably heard these things being used in Qatar, in Doha. This headline says Qatar gets its first robot waitress. This is a restaurant not far from where I live. So these robots roam indoors. You may have also seen robots, autonomous vehicles running about in where I work, the education city, where they use these things to deliver food, also in the service sector. And the news was that they run it in January of 2020 when the weather was cool. And we have some technical concerns, technical questions you need to address when you run this during the summer months. I also found this website, this from this company, it's called Dronico. They, on their website, they claim to offer airborne delivery within minutes within a city by flying drones to pick up your package and deliver it to where you want it to go. That sounds like a very exciting idea. And that's another that's another category of autonomous vehicles, so unmanned air vehicle or UAVs. In my opinion, flying in the air is more challenging from a technical sense, also from a legal, municipal sense. It's more challenging to fly. So I'm currently working on some unmanned ground vehicles. So here I show a photo. This is on the lower right corner of this slide. It shows you the map that a robot is building. You can see that the rectangular highlighted the square inside the image that appears to be blue in color. That's the robot itself, and then it uses this technology called the LiDAR, which stands for light detection and ranging. Its name is similar to radar, but it uses a different concept, similar but different concept than radar. It's commonly used in autonomous vehicles, except Tesla cars. So there are things that we need to learn about how to run these things in Qatar, especially if you want to run it in an outdoor environment. So I'm going to sum up things, and just because the subjects are very broad, and then if you want to discuss in detail, I'll be happy to offer more specific information that I have knowledge of. Um, but my thoughts for anyone who's interested in entrepreneurship that has to do with autonomous vehicles, you can do one of the two. You can buy autonomous vehicles and find a good application for these robots. For example, you can do delivery, you can do public health monitoring, which is one thing that I am working on. And then, of course, you can use that to do a solar PV power plant monitoring. And then this is actually a existing business model. People in China, in Singapore, and in many other countries, in Germany, have been flying drones to monitor the health of solar PV modules in large power plants, and they can spot so-called hot spots, and maybe perhaps even other defects that these solar modules can have, so that they can tell the plant owner and the operator, you need to address this module number such and such, because it's not operating properly, so that you can avoid further loss of production and potentially a more catastrophic event from happening. And then a higher level of business opportunities to manufacture robots for Qatar's environment, because I truly believe most of the autonomous vehicles, especially the ground vehicles, they're not designed for Qatar's environment. And people need to learn how to, what needs to be done to make the unmanned ground vehicles to be able to operate in Qatar's environment, hot, dusty, and humid. And then if you are smart enough, and then if you're ambitious enough, you can be one of the first people to open a line of robots that has your own brand name. And that's something that I would suggest to a ambitious entrepreneur. So here to summarize, so we talked about the soiling mitigation for solar power plants, utility scale solar power plants. There's business opportunities there, and you can, if you have a connection, you can talk to them and see what they want to do and help them out and make money that way. And you can do business with or make autonomous robots, mobile robots, or autonomous vehicles. And I mentioned several possibilities. So with that, I'd like to end my presentation, and then I'll be happy to address any questions if you have.
Ladies and gents, I repeat, Dr. Bing is interested to receive your questions and comments if you have any. Well, it seems that no one has any questions so far, Doctor. So I appreciate all the information and all this great information about the challenges of the solar panels in Qatar and about the robotic vehicles. Thank you so much for this great workshop. Our dear audience, you're welcome. Our dear audience, thank you for supporting our event by attending. We hope you enjoyed the experience and received beneficial information, and see you in our next workshop. Thank you. Wait, I think there's someone asking a question in Arabic. It says, is there a way to store solar energy with more innovative means?
Okay, I'll be happy to address that. The most convenient, the most readily available way to store solar energy is to store the electricity that you produce from the solar panels into a battery bank. And you know, Elon Musk has made a lot of money by diverting his Tesla car battery to Australia some time ago when his Tesla car production was experiencing some difficulty. And that was for that purpose, to store energy that's produced from a power plant like a solar power, PV power plant. There are other more innovative ways. So, but it depends on where you are. For example, I've seen, I think it's also in Australia, people have devised ways to use mechanical energy or gravity or potential energy so basically when you're producing electricity, you can pull some heavy rail cars uphill and then you keep them there. At night, you let those heavy cars run down the rail while pulling a generator, and then you store energy that way. But you can see that's only possible when you have a abandoned mine. You have this elevation change, and you can utilize that method that way. Certainly, you can also pump water to a water tower when you have electricity, and then use the energy when you don't have the sun. So innovation really has to be adapted to the local environment, the existing conditions.
Okay, doctor. There is a follow-up from Ilham. I think she's continuing the question. She's asking. Yeah, she's asking about.
Yeah, store energy so that it is sufficient for a restaurant or hospital or even batteries so for direct use. For smaller scales, actually you can over the summer I bought a larger battery bank from Amazon. It's bigger than what I was allowed to carry on the airplane. I think it was 300 watt hours, something like that. I can take it on a camping trip, which is quite useful. And it's able to sustain my laptop for a few hours. And then, so if you have a small family, you can count on this big battery bank to support your use for a day, maybe. And this can be perfectly feasible to be charged using a solar panel. In fact, this manufacturer that I bought the battery bank from, they offer this option. They sell you a properly sized solar panel so that it can produce the right amount of energy, electricity, so that you can use to charge this battery bank. So for that level, it's definitely doable. And then even for a restaurant, and certainly the scale will have to be larger. And I think that there may be some innovative people in Qatar that's already doing that. Shipping lithium-ion batteries is a very expensive thing to do now. So if now the land border is open, maybe the shipping cost can be reduced if you want to ship large quantities of lithium-ion batteries. Okay, I see another question which needs to be translated.
She's basically she's thanking you, and she says that she benefited a lot from this workshop for her. I think she's working on a thesis at her own university.
Okay, sure. I'm happy to hear that, and you're welcome.
So, our dear audience, does anyone have any question for the recently joined attendees? Mr. Jonathan Habash, do you have any question?
That's okay.
That's okay. Yeah. Okay, Doctor. Thank you so much for the effort, and wish you all the best. And we conclude this workshop, and hopefully we will see you in our next workshops by Road. Thank you so much.